Single replacement reactions follow a pretty simple pattern. A, an element, reacts with BC, that's a compound, to form AC, a different compound, a new compound, and B, a new different lone element. Single replacement reactions always start with an element and a compound, one element and one compound, and they always end up with the same thing, one element and one compound. But it's important to remember that the products are always going to be a different element and a different compound than we started with. Another thing we need to pay attention to is what kind of lone element we are starting with on the reactant side. Most of the time, the starting element is going to be a metal. We'll talk more about that later. For now, just know that it's important. Here's an example of a single replacement reaction. When solid lithium metal reacts with an aqueous solution of NaCl, that's sodium chloride, table salt, the reaction produces solid sodium metal, which is really reactive. It's honestly pretty dangerous stuff, as well as a new aqueous solution of lithium chloride, LiCl. Just like our pattern tells us, we're starting with an element and a compound, and we're ending up with an element and a compound. Do you see that the original element was a metal? Lithium, that's a metal. Most of the time, single replacement reactions start with a metal as the lone element. When this is the case, when we've got a metal all by itself at the beginning of the reaction, that metal is going to fight the other metal that is inside of the compound. So here sodium is the metal inside of the compound. So that's who lithium wants to fight. Lithium is trying to steal sodium's nonmetal so that he can get into the compound and kick sodium out. They're going to fight and they're going to switch places. That's why sodium ends up all alone at the end. Sodium is our lone element on the product side because he got kicked out of the compound by lithium. They switched places. We see the exact same thing happen when strontium metal reacts with magnesium hydroxide, MgOH2, to form magnesium metal and strontium hydroxide, SrOH2. Strontium is our element at the beginning, and it wants to steal magnesium's girl. Strontium wants to get into the compound and kick magnesium out so he can have hydroxide all to himself. So magnesium ends up alone in the end. So far, we've been saying that single replacement reactions are mainly metal elements fighting each other to steal the nonmetal and get into the compound. But sometimes it works just a little differently. The pattern doesn't change much, you just have to pay a little more attention when you write it out. Just like our other single replacement reactions, we always start with one element and one compound, and we always end with a different element and a different compound. We just see some of the elements switching places. Most of the time this happens between metals, but sometimes the starting element is a nonmetal, which means that the nonmetals are going to do the fighting and switching instead of the metals. When that happens, the nonmetals you're working with are probably going to be halogens. This is a special group of nonmetals, and they're all in group 7A, all the way near the end of the periodic table. They're in the next to last column, and they like to fight over the metals. Here's an example of that. Pure elemental chlorine gas. Okay, this is highly toxic stuff, and it was even used as a chemical weapon during World War I in Europe. When this element, chlorine, reacts with iron 2 bromide, the reaction forms pure elemental liquid bromine. Yes, bromine is a liquid at room temperature, not a gas, and iron 2 chloride. Do you see that the iron, that's our only metal in this reaction, do you see that it doesn't move anywhere at all? Instead, the chlorine and the bromine have switched places. These are both halogens. They're both nonmetals. This is because we started with a nonmetal element. We started this reaction at the very beginning with a halogen all by itself. That's chlorine. And since those guys like to fight over the metals, chlorine and bromine, they had to switch places. So let's try to pull all of this information together. Single replacement reactions followed the same general pattern of an element and a compound switching around to form a new element and a new compound. Most of the time, the starting element on the reactant side is a metal. That means that the metals are going to fight over the nonmetal, and they're just going to switch places. But sometimes the starting element is a nonmetal, and most likely, if it's a nonmetal, it's going to be an element from the halogen family, like fluorine, chlorine, bromine, or iodine. In this case, the two nonmetals are going to fight over that metal. So we'll see the two halogen elements switching places instead of the metals. The metal in this case just stays put. Here's the big idea. Metals replace or switch with other metals. Metals replace metals. Nonmetals replace nonmetals, and most of the time these are going to be halogens. In every single case, whoever is switching around is going to be determined by what kind of element is starting off alone. If we're starting with a metal, then the metals are switching. If we're starting with a nonmetal, then the nonmetals are switching. So, focus on the starting element. Okay, here's a real example. Rubidium reacts with potassium hydroxide. Okay, well, we see rubidium, that's a metal element, it's Rb, and we see potassium hydroxide. So Rb must be reacting with KOH for potassium hydroxide. Watch out for that polyatomic ion, don't let it trip you up. Remember, we always need to also pay attention to what our starting element is when we're working with single replacement reactions. Here, we're starting with rubidium. That's a metal. So our starting element is a metal. That tells us that the two metal atoms, Rb, rubidium, and K, potassium, are going to do all the fighting here. They're going to fight it out. So the reaction produces solid potassium metal and rubidium hydroxide, RbOH. That means our final correct chemical reaction equation is Rb reacts with KOH to produce K plus RbOH. Rubidium, a metal, is our starting element, and it switches places with K, potassium, which is another metal element, to form rubidium hydroxide as our new compound on the product side. You want to try another one? Just to make sure you've got it? Yeah, let's do that. Elemental fluorine gas reacts with calcium chloride. So I guess that's all we're given. What do we know? Well, we know we've got fluorine. Okay, when it says elemental fluorine here, it's telling us that it's fluorine all by itself, just the pure lone element, not in any sort of compound. We're also told that the fluorine is reacting with calcium chloride. We're not told anything else, so let's see what we can start writing out. Fluorine is a diatomic element, so we need to write F2. And it's reacting with calcium chloride, that's CaCl2. Make sure you check your charges when you write Category 1 or Category 2 formulas. Don't forget about your naming and formula writing rules when we're going into all of this information about reactions. And these are the only reactants mentioned, so we know we can go ahead and draw that arrow. But now what? We see that we're working with an element, that's fluorine, and a compound, ClCl2, calcium chloride. Oh, so this has to be a single replacement reaction. That means we need to consider what type of element we're starting with. Okay, fluorine, is that a metal or a nonmetal? It's a nonmetal. It's a halogen. It's from group 7A. This is a single replacement reaction where two nonmetals are going to replace each other and switch places to form a new element and a new compound. That gives us elemental chlorine gas as our new element and calcium fluoride, CaF2, as our new compound. The nonmetals have switched places. Remember to pay attention to what kind of element you're starting with. Metals replace metals and nonmetals replace nonmetals. Always pay attention to what kind of element you are starting with in a single replacement reaction. Here's an example to try on your own. Pause this video and press play to check your answer. In this reaction, we see copper metal reacting with aqueous silver nitrate. If we write that out, we're going to get Cu plus AgNO3 reacting together. Since we've got a lone element and a compound reacting together, this must be a single replacement reaction. That means we need to consider what kind of element we're starting with in order to figure out how to write the products. Our starting element, copper, it's a metal. So that means the metal atoms are going to switch places. We can write our products as silver as the lone element and copper 2 nitrate, CuNO3 Now, because copper is a green element, it's a transition metal that doesn't always have the same charge, we need to be told which charge to assume. Notice that the original reaction up here tells us that this is copper with a 2+ charge. We call that copper 2. That is where we got the 2 at the end of the copper 2 nitrate formula. If you have questions about this, go back and look over your formula writing and naming rules for category 2 compounds, transition metals and nonmetals. So our final chemical reaction equation here should be Cu plus AgNO3 reacting to form Ag plus CuNO3 How'd that go? Use the practice examples I've given you to keep working on single replacement reactions. Don't forget to check what kind of element you are starting with. Remember, metals replace metals, nonmetals replace nonmetals. Check your answers as you practice and ask questions when you have them. Good luck!